What is up, my beautiful people? Christian King coming at you again with a new series, actually. Rather than bot tutorials like we've been doing, I'm going to go ahead and do a Unity tutorial. This is actually the only projects I have on this computer, but on my other computer I actually have dozens of projects that I've been working on. These are all for school. These two are the same, so don't worry about those. Anyway, as you may know, I'm a game developer, and I recently graduated and got my bachelor's degree in game design and systems thinking. So that's not an actual degree, but it was tied in a little bit, systems thinking and systems engineering. But what I want to do is I want to be able to give some of the knowledge that I have and pass it on to you. So what we're going to do in this video is I'm actually going to teach you how to, instead of using Unity's built-in character controller, that's what it's called, we're going to create our own with some realistic physics, as close as we can get to realistic, actually. But let's go ahead and start. Let's get right into it. Let's create our project. Call this Unity Tutorials. And where do I want to save this? I want to save it in a folder I created for Unity Tutorials. We're going to do 3D, like I said. So we're just going to create that, and we're going to let it build and compile the project. So unlike discord.js is going to take a lot of waiting. Not a lot, but more waiting. But we'll just give it a second, let it think. Alright, so we are in engine now. So as you can see, yours might look a little different. Your editor might look a little different than mine, which is totally fine. I don't think there's a right or wrong way. Whatever way works best for you. But personally, what my thing is, I like to be able to see my scene and my game at the same time. If I don't have these two working at the same time, I'm not doing it right. But a good rule of thumb is you want to have your console, your project folders, your scene, game, inspector, your lighting, your hierarchy, and then your animation if you're using it in your profiler. I won't get too much into what the profiler does right now per se, but maybe in a later video I'll start to help you out with that, because it can get a little tricky in the profiler at times. But as long as I have all the how do I do this? As long as I'm able to look at everything that you can see right now. Oh, and don't forget project settings. I'm just gonna put this right back over here. Bit off a little more than I can shoot, but yeah, as long as I can see personally the scene, game, hierarchy, inspector, lighting, profiler, animation, console, project settings, and project folder, I think I'm good to go and I'm all set. But anyway, I'm going to turn this music down just a little bit so I can hear myself think. But what I want to do anytime I'm working in Unity 3D, I want to add a package called Pro Builder. So we're going to go to our window, package manager. We're going to wait for it to fetch all the packages, and instead of in project, we want to do Unity registry. So I'm just going to type in Pro Builder, and I know I'm going a little fast here, but this is just because this is some basic setup. So you're going to type in Pro Builder, enter, install the first and only thing you see. Let that install, do its thing. And it might take a little bit at this last tick, like it always does. So let's go ahead and just listen to this fun music while that downloads. Alright, cool. Enough of my crappy dancing. Probably didn't like seeing that. But anyway, what we're going to do, and if we did it correctly, we're going to open up packages and see right here that we have Pro Builder. I want to grab it. We're going to hit Tools, Pro Builder window. I like to pull this right next to our animation tab right there. So, first and foremost, we want to create a little way for us to be able to actually walk. Because if I were to put in an object here with physics on it, just fall straight through the map. So what I'm going to do, new object, let's do a cube. We're going to do on the X, we're going to do 100. On the Y, we'll do 0.5, and on the Z, 100 as well. Just want to create a big ol' object for us to use, like so. I'm going to go ahead and grab this object, and on our position right here in the inspector, I'm going to do -50 and then +50 for the X and the Y. That way, if I were to put a new object right in the smack dab in the middle of the origin of the world right here, it would just be right in the middle. And I'm actually going to drop this down to -0.05. So now that we have our cube in here, we can go ahead and rename our cube the floor, and we want to give it a tag because eventually we're going to need the tag. We're going to add a tag and then name the tag floor as well. Come back in here and assign it like so. Save our scene. I like to save as much as possible in Unity because it's so finicky and it's so screwy that sometimes it will screw you over. Next, what I want to do is I want to create another shape. We're going, instead of a cube this time though, we want to create a, where is it? It doesn't have a capsule, so we're just going to do a cylinder. The radius we will do 0.25. The number of sides, I want to crank it up to the max just because it makes it as round as it can possibly be. Height, I'm going to do 1.25. And height segments, don't worry about that. Smooth, yes, we want that. We're going to build that out. And I like, just because of my OCD, I want to reset the transform to be in this at 0. And as you can see, this is why I created moved our floor down a little bit. Anyway, now that we have this, let's go ahead and rename this cylinder the player. Give it a tag of player, and it doesn't look like it added the player. Let's try that again. Player, oh, duh. There's already a player tag. We don't have to worry about that. Now, so if we're working in third person or first person, that's all your own, and everything's essentially going to work the same. But for all intents and purposes, I'm going to work with a first person controller. So I'm going to take the camera, which, if you didn't see that, our main camera, I'm just going to drag it on top of the player and make it a child of the player. We're going to come over here and reset the transform. And as you can see, it went down to the player's like feet essentially, but these are all primitive shapes. I'm going to drag this up just right about there. And then I want to drag this over to the side a little bit so it's right smack dab in the middle of the player's face, if there was a face there. I'm just going to keep this very simple just for this video. I'm not going to do any sort of character rigging or animations for right now, but we have our player and our main camera. Now what we want to do is we want to actually set up our scripts. We're going to come into our assets, right click, create new folder. We're going to name the folder scripts folder. And now what we can do is we can right click our scripts, create C# script, and we're going to call this player controller. And I spelled controller wrong, but that's fine as long as it works. And we're going to drag this script onto the player itself, and then now we want to open that script up. And here's what we need to do. So what we're going to do is we are going to first call some objects and some variables. Here we're going to create some. So the first variable we want to do is we want to create a private, well actually, so a little thing about when we're using Unity Engine and whatnot, by default everything is private. So you don't have to really write private. If you want to create a private variable, you can just type out the type of variable it is, but unless you want to make it public, you have to type out public. But for here, I'm actually going to just type in rigid body. I want to make it a private variable, and we're going to call this player. I'm actually going to serialize this field. So you can either do it above. I like to do it next to it. So we're going to serialize the field right there. What we're also going to need is a few different floats and booleans. So what these are for are floats. What we first want, actually, now that I think about it, the player's physics, right there, cool beans. come right here and we're going to do our movement variables. And let me just come over here and then, alright, so movement variables, what we want to do for this is we want to first create a float for our speed. I'm going to make it public for this, just so we can make sure we're watching it. We're going to make a public float for our speed. We're going to set that to 10. Oops. We're going to create a public float for our gravity. We're going to set that to negative 9.81. And if you want to know why this is so specific to negative 9.81, that is the gravitational constant of our actual real-life gravity in the world. Probably already knew that, but I just wanted to make sure I went over that in case you were unaware. Be like, why is it negative 9.81 and not just negative 10 or something? But like I said, this is as close to real world physics as possible. We're going to create a public float for our max velocity change. And as you can see, what I'm doing is I'm camel casing all of my stuff right here. So as you can see, I'm not capitalizing speed, I'm not capitalizing gravity, I'm not capitalizing max. I'm camel casing it because when we save, what will automatically happen if I come over to our editor right here, we're going to look at our script. Once it's done compiling, it'll automatically capitalize it for us. Whoops, didn't want to do that. So we're going to come over to our Unity tutorials again, and now I just want to create a Boolean, and this Boolean is going to be can jump. I'm going to set that to true. And actually, before I even get into that, I'm going to first start setting some of this stuff up. I'm going to come into oh yes, and we also need our movement vectors. So what we need a public vector 3. Okay, I was for some reason looking for the variable name, but our vector 3, we're going to call it a target velocity. And we need a public vector 3 for our actual velocity. And what this is, we're actually going to get into a little bit of physics here. I'm just making sure we have all of our stuff set up. So now we have our basic movement variables. We can get into what we need to do for the start. So at the beginning, what we're going to want to do, I want to call this assigned movement variables. Here we're going to do player dot freeze rotation because we want to freeze its rotation. We're going to do player dot use gravity since we're using our own gravity, which will be created here in a second. And we're going to set this gravity immediately. Sets the player's gravity. Instead of this, I'm actually going to go 1, 2, 3, 2, 3, like so. So sets the player gravity. We're going to do gravity equals -2 times our, and actually we do need this. This is our jumping stuff. So we're actually going to create another float, public float, and it's going to be our jump height equals, let's call it 2. So we're going to create a set of jump height to 2 units up, and we're going to set a peak time, public float time to, okay, whoa, time to peak, and we want this to be very short. Since the jump is not long and delayed, we want to make it quick, up into the peak and then right back down. So up into the peak, let's give it a 0. Might be a little too much. Let's give it 0.25 for the time to the peak. So now what we want to do, we want to come back down into our gravity equation that we're setting up. If you're unaware of what we are using for the gravity. I'm gonna go ahead and pull this over. What is it? I gotta find it first. Okay, I think this might be it. This is not it. Okay, anyway, but what the equation that we're going to be using is we're going to be basically taking the jump height, which is how high the jump is. We're going to divide that by the time to peak squared, multiply all that by 2. So what we're going to do is we're going to do -2 times our jump height over the math f dot pow for power of time to peak, and this root value, or the power that we're multiplying it is 2. So this equation is the -2 times the distance over the time squared. So now what we want to do is we want to come down into our, just making sure, okay. Alright, cool. So we set up our movement variables. Now we want to update. So what we want to do is we actually want to set our movement. And first off, actually, now that I think about it, I would like to create our movement first. So what that is going to look like is we're going to go out of our update. We're going to do public void move. Not on animator move. Public void move. Just like that. So we want to create a vector 3. We're going to call this temp velocity. So temp velocity equals our new vector 3. And we're going to call our player dot velocity dot x. We're going to do 0 for the y because we're not really moving on the y. And then finally on the z, we're going to do player dot velocity dot z. Close that off, and we want to calculate how fast we're actually moving. Calculate the speed at which the player moves. Give me just a sec, guys. Hold on. I'm getting notifications. Am I? No, I'm not. Okay. Coming back. Sounded like I got a notification. So now we're going to do player dot add force. And the force that we want to add is we want to add the target velocity minus the temp velocity. So the target velocity, which was our which we haven't assigned yet, actually. I think I need to get into assigning that. I'm all over the place for this one. Yes, so we need to assign this temp velocity. So before we get into this, I'm sorry about that, people. We do have to go into our update. So what we're going to do is we're actually going to create our target velocity, or assign our target velocity. So we're going to say the target velocity equals new vector 3, and we're going to do input dot get axis, and not just get axis, we get axis raw. And the axis we want to do is we want to do our horizontal axis. And we want to make sure that we're spelling horizontal properly right here. So horizontal times speed. So this is how fast you're moving on the x. We don't need to calculate anything on the y. I'm just going to copy and paste all of this because we're going to do the same exact thing for the y, but instead of horizontal, we're actually going to do vertical. Oops, vertical right there. Cool. Go ahead and close that off. So now we want to do target velocity equals transform direction in the target velocity. So what this does is we're just saying how fast we want the target velocity to move. So if I hit the W and S, we're gonna move that at that speed. If I hit A or D, we're gonna move at that speed. We don't need anything for the Y yet because we're not calculating a jump. And so what we want to do now is say when I have my camera eventually, I want to set it so target velocity, and we're wanting to change that direction of whatever the camera is looking at. So now that we have that, we're all good to go. Now we want to go into our move function once again. So now since this is happening every frame, so every frame this is going to be ran. So once again, come to our move, and now we want to do calculate how fast the player moves. So again, player.add force, not explosion force, but add force for our target velocity, because we calculated how much it was. Then we're going to subtract our temp velocity. We're going to do force mode dot velocity change, since we're wanting a change in velocity. We're going to go player dot add force again, and this time we're going to create a new vector 3, and in this vector 3 we want to do 0 on the X, gravity on the Y to make it the player hit or always go to the ground. So if we jump eventually, since as you can see we're not using gravity up here, but we're wanting to calculate it right here. So again, we're always wanting the player to hit the ground and go towards the ground. So we're going to do gravity 0 for the Y, or for the Z, and again, force mode. Instead of velocity change, we're doing acceleration because gravity is an accelerated force. Close that off. If, and this is if you want to actually create a boost. I'm actually looking at an old project of mine right here, by the way, just to make sure I'm following properly. I won't get into that yet, but let's go ahead and save all of this real quick. Let me do a void fixed update. I'm going to throw in move and close it off. Just make sure that is all good to go. Yes. Alright, so as you can see, I put move in fixed update rather than update, because when using get access or get access route, or really any sort of movement variable, what happens is in update it can get a little glitchy at times. So since it's running every single frame, but if we do fixed update, which will do every update within 60 frames per second is when fixed update runs, it will only do those 60 frames rather than update being every single frame. So say we're running at 120 frames, it won't act all weird. It's just a lot easier, and it looks a lot nicer if we put it in fixed update. The movement is a lot nicer. But anyway, let's come into here since we saved that. So we have all of our variables right here and whatnot. So we have to assign a rigid body real quick. So we're going to go to add component, and we're going to do rigid body. Make sure we are, for our constraints, we're locking our rotation just to double it up in a sense. Use gravity, correct. And now we're just going to drag this rigid body into our rigid body component. So as you can see, we have our speed at 10, our gravity is negative 9.81, our max velocity change is 5, jump height is 2, time to peak is 0.25, and we have nothing in our velocity or target velocity yet. I'm going to go ahead and hit play. And we're going to see these values change real quick, and I'm going to explain. Whoa, hold on. Let me add a box, not 2D. Let me add a box collider to the floor real quick. So, that was not good. Uh-oh, why do we keep falling through? Let's figure this out. We should not be falling through the floor. Did someone join a voice call? Am I in a voice call right now? No, I'm not. Okay. Anyway, I am falling through, and I want to figure out why. Use gravity. Make sure use gravity is unchecked. So we're gonna hit play again. I think this might have been why. It is not. What in the heck? I apologize, everybody. Alright, I'm going to move our player up just a little bit and see if maybe he's in the floor and if that's what's causing it. No, he still falls through anyway. Okay, let's do some troubleshooting. Let's see why non-vex is no longer supported with Unity 5. Maybe this is why. We're going to set our collision detection to continuous. Maybe that will work. Use kinematic for the player. No, so he doesn't fall through if we're using kinematic. Again, guys, I'm really sorry. I don't know why this isn't working. Yeah, what the heck? Well, this is a bummer. That's not good. Let me just make sure. Coming back into our script real quick. Unity tutorials. So we have freeze rotation is false. Our gravity, or true is our gravity is false. We set our gravity right here. Maybe it's because I commented all this out. Like, essentially, I'm going to save that real quick. If that's it, I'm a big dumb. Nope, okay, good. Okay, hold on. This is frustrating. I'm sorry, everybody. I'm really, really sorry. Okay. Ay, ay, ay. I forgot two very important variables we have to assign. We never assigned our max jump height, which we actually need to create a variable for our max jump height. So right here, we're going to create a float, and I want this to be a private float. So we're going to do max jump height, and we don't want to assign anything because it's going to be automatic to the jump height right here. But what we're going to do is we are going to come down into our update once again. It is right here. So max jump height equals, we're going to multiply this. We're going to multiply 2 to the jump height over the time to peak. So again, similar to what we did for the gravity, we're taking the distance divided by the time and we're multiplying all that by 2. We're just going to take the velocity real quick. I'm going to make sure that's assigned to the player.velocity. One quick rundown real quick again. So yes, we have everything should be set up properly. Again, guys, I don't know what the heck happened there. I'm hoping this fixes it. If it's not, it could be the updated version of Unity I'm working with. So let's see. So that still makes us fall through the map. Okay, that is very interesting. I really, honestly, I'm at a loss for words. What I'm gonna do is I'm gonna just take this off. Send it into his own thing. Get rid of him. And I'm just gonna do this. I'm gonna create our own game object for a capsule. I never have issues with our capsules. Reset. We're gonna move him up right there. Throw our camera onto our capsule. We're gonna reset our camera. We're gonna move him up as if he was in the player's head. Give this our player tag. We're going to add our, not our box collider, our rigid body, and then our player controller onto that. Drag our rigid body into there. We're gonna make sure this works. If it doesn't work, I'm gonna be very sad. Okay, yeah, so there we go. As you can see, it's a little fast, and we don't have any sort of way to move the camera at this point, but our speed is normalized, it looks like. Let me just make sure. Okay, so it's not. So our speed is still, so we can move this way or this way, up, down, left, and right, and the speed is going to be at 10. But if I hit A and S at the same time, we can see that I start to move a lot faster than I normally do with just one key. So what we're going to do is we're going to normalize our speed real quick. For that, we are going to go into our script, and that should just be a normalized variable. Let me just figure out where to put it real quick. Okay. So we're going to put our normalized velocity. Our target velocity is actually dot magnitude dot normalized dot magnitude. Didn't think that would work. So it's not temp velocity that I'm wanting to update. Alright, still might be target velocity dot normalized dot magnitude. No. Okay, so that did work. Let's go ahead and see if the target velocity dot normalized, if that will work. Alright, so no, it did not work. It made us very slow. Let us put it in or vector 3 player velocity equals player dot velocity dot. Let's try that normalized. That should work. If it doesn't, then we'll try something different. So yeah, so it looks like it's moving a lot like at a normal speed now. It's kind of hard to tell, but yeah, no, okay, so that's moving at a normalized speed now. Cool. So we have all of that. Now we want to add a jump. We want to make the jump, or we want to be able to add a realistic jump as well, and that's why you calculated all these different jump heights and whatnot, and calculated our own gravity. So what we want to do is we want to come back into our script right here, and we're just going to create a boolean real quick. I'm going to make it under our max jump height. We're going to make a public bool equals, we're going to name it first. We're going to do can jump, and we're going to set that to true, like we did at the beginning. And we're going to come into our start, sets the boolean for the jump. We're going to do can jump equals input dot get button down. So we just want to say that the button went down, not button, because it's going to say as long as the button is being pressed. Or get button down is jump, which is a pre-made Unity function, and we're going to come down here to public move or public void. We're going to create a new public void. We're going to call this jump. And then inside of the jump, what we want to write is yes, we want to actually create another variable boolean as well, and this is going to be a private boolean. Bool grounded equals, I think grounded is false. Let me double check. Grounded is indeed false. So we're going to set grounded to not fail, so whatever that was. False. Cool, cool, cool. Let's come back into our jump. So we're going to do, in our jump function, we're going to do if grounded and can jump and gravity is greater than or equal to 0, we're going to say velocity dot y is equal to the max jump height. which, like we did up here, we already set our max jump height is our 2 times jump height over the time to peak, so our 2 times distance over time. We're going to do player dot velocity is equal to velocity, basically the exact opposite of this right here. And we don't need normalize because we're only doing one input. We're going to do can jump equals false, and then finally grounded equals false. Cool, cool, cool. So now what do we want to do here? Oh, and finally we actually want to create another else if not grounded and gravity is greater than or equal to 0. So if we're not grounded, then gravity is equal to 0. Can jump, we want to again just default it to false. Cool. Okay, so we created our jump function. We're going to go ahead and throw it into our update. Calls the jump function. And we're going to say jump. There's a little bit of a key though. As you can see, when we start, we're not able to jump. So we're going to have to work with Raycast. So we can move and whatnot, but we can't jump. So what we want to do is we want to come back into our script here, and we're going to want to create a public void. We're going to call this ground. Ooh, no. Ground check. So we're going to check if the player is on the ground. Here's where we're going to get a little tricky. Again, we're going to be working with Raycasts. So we're going to go Raycast hit. This is our first variable. We're going to call that hit. We're going to create a distance variable. We'll say dist is equal to 1.1f. And then we want a vector 3. And we want to call this the direction, and this will be the negative transform dot up. Cool. So let's start working on this Raycast. So what we want to do is we want to say if physics dot Raycast is on the, and we're going to assign it to the player dot transform dot position. That's where the position is always going to be. And actually, so we can see that we, while working with Raycast, we have the, okay, gotta go back up. We have the ray of where the ray's position is, and we have the distance of where it is. If we go down, we're actually going to be working with this one right here. So the origin, no, not that one. Yes, okay, so if we're working with Raycast, we have different kinds of ways to set up the Raycast. We have the origins point of the Raycast. We have the direction of the Raycast, which is our direction. We have the distance of the Raycast, which is this distance. So we're going to do, like I said, the origin. Now we're calculating the direction, which we assigned right here. And we were assigning the, or we want to make sure it gets hit as well. So we call the hit. And then finally, okay, hold on. It's not, okay, so yeah, so we have, again, origin, direction in the hit, and then the distance, so dist, right there. And then now we want to open it up. So we're going to go debug, and this is just for our purposes. This won't show up in the game. We're going to go debug.drawLine, no, draw ray, actually. And we're going to go player.transform dot position, since we're trying to draw the ray's position right now. We're going to go with the direction times the distance. So the direction is going and the distance it is going. We're just going to color. Okay. We're just going to color it red, just for our purposes. Now we want to set, so if the ray hits, we want to set grounded to true. And just so we will, if we want to, we can go debug.log player grounded. Cool. Alright, now what we want to do is we want to set a way for like the player to not be grounded. So we're going to go else. No, not else. We're going to go if the physics, basically we're going to copy and paste all of this into here, but a not. So if it does not happen, we don't want the player to be grounded. We're going to set the grounded to false. And again, I know this is a lot going on. This is a 40-minute video. It's very long. I apologize, but there's a lot going on when we're creating a realistic movement here. So now what we want to do before we jump, we want to check to see if the ground or if the player is grounded. So we're going to go ground check. So what we're going to do is we're going to check to see if we're on the ground, and if we are, we're going to be able to run the jump. So finally, let's run over to our Unity engine right here, our editor. So we're going to be able to not only walk around, but we can also not jump yet. What is going on? It says the player is grounded. What did I not put in? There might have been something I didn't put in. Did I assign the variable? Jump. Start can jump. Ah, okay, so this needs to go into update, not start. So I'm going to just assign that. I'm going to assign that right there. Oops. There we go. Okay. So, uh-oh. Ah. Okay. So now we're going to be able to run around, and it's saying that the player is grounded, and we can jump. And look how nice and clean that is. It's a quick little boing, boing, and it instantly goes back up and then hits the ground. So, in the next video, I will show you how to create the camera, and then along with the camera, I will also create a little bit of an enemy so the player can be followed and track an enemy as well. But yeah, so that's the player controller right there. I hope you guys enjoyed it. I hope I didn't go too fast and there was some information I didn't touch, but a quick little recap of what we did is we created all our variables and our different velocities and accelerations, and we made sure we locked the player's in-game physics so we could create our own gravity, which we used the -2 times the distance over the time squared. We assigned our jump height by doing 2 times the distance over the time. We set our player's velocity. We set the target velocity by multiplying the distance times the speed. We created our move function where we said that the player's velocity.x and z are the player velocity, and then we added the force to the velocity change, and for gravity we just added the acceleration because it's an accelerative force. We created our jump by calculating the velocity of the y, and then we said that if the player is grounded, they cannot jump. We created our raycast to see if the player is on the ground, and if they are on the ground, they're able to jump, and if that raycast hits, we jump. But like I say in all my videos, if you ever have any questions, please feel free to hit that comment section. I'll be sure to check those as much as possible. And if you can't do that, please come to our Dev Eyes server right here, where we are definitely willing to answer any of your questions in our tutorials channels. But yeah, I'll link this in the description as well. So I hope to see you there. I know it would mean a lot to me and Curtis to have you join, just to hang out, even if it's not going to be for getting your questions answered. But like I said, we are at your disposal. If you're unable to figure any of this out, we are here for you. But if you like this video and you want to see more content like this, please hit that like and subscribe button, and along with that bell notification so you can be alerted when we push out more content like this. Anyway, I'm sorry this video ran so long. It was very information heavy. And if you don't understand any of these physics, please join the server. Enter it in the comments section. Enter it in the server tutorials section and channels, and I'll help you out and explain these physics a little more to you. Like I'm a physics nut personally, but anyway, I hope you enjoyed this video and you're able to understand how to create a personalized mini physics engine for your player, so you don't have to use the like I'll just go right here. So they have a character controller. It works for the most part, but if you're creating a game with very heavy physics related, this is the best way to go. But anyway, like I said, thanks for coming by. Hit that like, hit that bell notification, and I hope to see you on the next one.